Hi everyone, welcome to this class on exponents. I'm going to make the topic of exponents really easy for you. So I'm sure your concepts will be crystal clear after watching this maths class. So guys, make sure to watch the entire video. And if you haven't checked out our website, do check it out. It's manochaacademy.com and we've got these exciting courses for you. So I have this exciting news guys that we've launched the full course for Maths CBSE Class 9 on our website. So do check it out. And we also have the Physics CBSE Class 9 full course and the Chemistry course. And we have the ICSE Physics Class 9 course. So guys, do check out these courses. They are at big discounts right now. You get to attend more live classes where I take more live classes. You have interactive videos, quizzes and questions. So guys, do check it out. The links are given below. And guys, if you haven't hit the like button, please hit it right now and do share it with your friends. And don't forget to subscribe to our Manocha Academy channel. So good evening, everyone, and welcome to this exponent class. And I'm going to make the topic really easy for you and also discuss the practical applications of exponents because exponents are used everywhere in maths and science. So let's take a look, guys. So guys, can you tell me what is the speed of light? And you'll realize that you're using exponents all around. So come on, I want all of you to try. So come on, guys. So tell me, what is the speed of light? So go ahead, who can tell me what is the speed of light here? Right? So you guys know that it's 3 into 10 to the power 8 meter per second. Right, guys? Very good. 3 into 10 to the power 8 meter per second. Okay. So guys, can you see that exponent there? 10 to the power 8. Because exponent, you know, it means the powers, which we are going to be talking about. Guys, can you tell me what is the mass of sun? What is the mass of sun, guys? Come on. Okay. Oh, somebody's asking what's my name. So my name is Sandeep Manocha, guys. And if you haven't subscribed to our YouTube channel, Manocha Academy, please hit the subscribe button right now and click on the notification bell. So guys, do you know what is the mass of our sun? It's a really big mass. It's 2 into 10 to the power 30 kgs. So this is the approximate mass, right? 2 into 10 to the power 30 kgs. And guys, can you see? Again, there's the exponent or the power there. Right, very good. I see Albert Einstein, Witty, Brainy, they have the right answer. Excellent, guys. So it's a huge mass. And again, can you see exponents are used? Now, guys, who can tell me? So these are all science related stuff, right? So maths and science, they're all together. They are friends, right? We use maths all the time in our science. So what is the number of atoms in 12 grams of carbon? Who can tell me? So guys, who can tell me? So here you can see this is carbon, right? Coal is mainly carbon. So if I take 12 grams of carbon, do you know what is the interesting number? How many atoms of carbon are present in 12 grams of carbon? Okay. I want all of you to try. Some of you are saying the volume is low. All right. I'll try to get the mic closer and I hope it's better. So I'm using the same microphone and I'll try to speak a bit louder, guys. Excellent, guys. Excellent. The famous Avogadro's number, right? Super. You guys are excellent. So the number of atoms in 12 grams of carbon is the famous Avogadro's number in science. So don't worry if you don't know these numbers, but it's this big number, right? 6.022 or 023, some books say, into 10 to the power 3 atoms, right? And so guys, can you see the exponents in here? Can you see these big numbers? 10 to the power 8, 10 to the power 30, 10 to the power 23. These guys, right? The raised to the power, they are the exponents, right? And that's the topic of today's video. Awesome. And you know that exponents can also be used for tiny things. So guys, don't think exponents are only used for large things. Okay? So guys, do you know what is the length of a bacteria? Does anybody know? So any biology experts here? What is the length of a bacteria? Again, I'm talking about the average length, right? So if you guys know, it's approximately 1 micrometer, right? And what is 1 micrometer? So guys, if I say length of the bacteria is 1 micrometer. So who can tell me 1 micrometer is how many meters? Come on. I want all of you to participate. Excellent. The math magic says 10 to the power minus 6. Superb. Right answer. 10 to the power minus 6 meters. Okay. So can you see? Again, exponents can be used for small things, right? 10 to the power minus 6. So who can tell me, guys, what is the charge of an electron? Charge of electron. Very good. 10 to the power minus 6 is the length of a bacteria, the average length. What is the charge of an electron? Come on, some science experts here. And guys, this exponents topic is relevant for everyone from class 7 to 10 and even for class 11 to 11 and 12, right? Okay, very good. I see Sapna has the right answer. 1.6 or minus 1.6, right? Into 10 to the power minus 19 coulombs. Okay, so the charge of the electron is a very tiny number because we have 10 to the power minus 19. So guys, you know that's 0.00000. You'll have like 18 or 19 zeros there, right? And so 1.6 into 10 to the power minus 19. Aditya Prakash also right answer. Superb. Okay. And guys, can you tell me what is the mass of one hydrogen atom? So again, it's going to be a tiny number. Okay. So who knows? What is the mass of one hydrogen atom? Come on. Okay. So yeah, some of you, so Adarsh Mishra is saying in atomic mass unit. No, I want it in kgs. Okay. Because we want to see the exponents here. Right. So let's say I want the mass of hydrogen atom in kgs, in kilograms. So obviously it's, you know, it's going to be 0.000000, lots of zeros. So it's very difficult to write. Very good. I see again Sapna is the right answer. She's saying in grams. So I'll write it in kgs here. So 1.67 into 10 to the power minus 27 kg. Okay. So it's a very small number, guys. Can you see that's 10 to the power minus these numbers? So this tells you that these numbers are very, very tiny. Okay. And it makes it very convenient. Can you see? With the help of exponents, we can express these large numbers very conveniently rather than writing, you know, speed of light with 3 and 8 zeros, right? So imagine writing it like this: 3 and 1, 2, 3, 4, 5, 6, 7, 8, right? You'll make a mistake. And these numbers are even larger. So exponents are used all the time in maths and science and very convenient to write large numbers like these and even small numbers. So don't think they're only for big numbers. Okay, guys? A lot of times students have this confusion. So length of bacteria is 0.000001 meter, right? Okay, but I'm not sure I told the number of zeros right. So we'll write it as 10 to the power minus 6. All right? Excellent, excellent. Superb, guys. And I know many of you writing the answer, so sorry if I'm not taking everyone's name here, but I want all of you to participate. And guys, please do hit the like button right now. So let's dive into our topic of exponents. So what is 2 times 2, right? So all of you know 2 times 2 is 4, right? And we express it in exponents as 2 raised to the power 2, okay? Right? And similarly, 2 times 2 times 2 is 2 to the power 3, right, guys? And here you can see 2 times 2, there's 5 times, right? So it's going to be 2 to the power 5, okay? Very good, right? And guys, do you know what is this number known as? So the main number that we write at the bottom, so this one is called, so 2 here is called the base, okay? So let me write that clearly here. So let's say I write, let's take this example of, let's say 2 to the power 5, okay? So this number 2 here is called the base, okay? And the 5, what is the 5 called, guys? Come on. So 5 is known as exponent, or it's also called the index, or simply we call it the power, right? So these are the terms used. So the number is called, very good, it's called the exponent, the index or the power, and 2 is called the base here. So we say 2 raised to the power 2, 2 raised to the power 3, or 2 raised to the power 5. And guys, what should I write for this last one? So 2 into 2 into 2, 100 times. Very good, guys. 2 to the power 100. And I see a lot of you are writing in the chat. So a lot of times in the computer, we use this notation, right? We use that caret symbol to denote power. But of course, in maths, you know, we'll write it to the power 100 like this. Okay. So a lot of times in computer, because it's difficult to type it in a line. So I see a lot of you are writing it like this, right? 2 with the caret and 100. That's also perfectly right. So it's 2 to the power 100. Excellent. And guys, you must have heard of this interesting story, right? Of the grain of rice and the chessboard. So once a king had said that, I think somebody pleased the king and he said, okay, you ask what you want. And he said that, king, I want you to take a chessboard and place 1 grain of rice. Okay, so guys, have you heard this famous story? So place 1 grain of rice. Okay, so just 1 grain here, right? And then from the next chessboard, you double it. Okay, and again you double it. And the king said, that's very simple. I'll give you that many grains. Okay, but can you tell me if we keep doing like this? So let's say we have 1 grain of rice here. Okay, and every time we keep doubling. So as we move along, we are going to double the grains. Okay, so who can tell me, guys, how many grains of rice would we need to put on the last chessboard, right? The last square, I mean, on the chessboard. Okay, so guys, can you tell me? So I'm asking if the king had to give every day a grain of the rice dependent on the which square he's in, how many grains you need on the last square of the chessboard here. So how many grains here? I'm not asking the total, just for the last. So come on, I want all of you to try. Okay, a lot of you are saying 2 to the power 64. Is that the right answer, guys? Think about it. So I want everybody to try here. Some are saying 2 to the power 50. Okay, so guys, let's take a look. So let's do it together. Come on. So on the first board, he said 1 grain of rice, right? The next one, he said double it. So it's going to be 2. The next one will be double of 2, right? So it's going to be 4. Then double of 4, 8. Then 16, 32, 64, and so on. You guys get the pattern, right? It's going to continue. But we are going to use indices, okay? We are going to use exponents and make this really simple so that we can find, because it's hard to calculate, you know, it's going to be a big number. So guys, let's try it. I'm not saying the right answer though. I think my answers, I think it's different. You guys are all saying 2 to the power 64. Come on, think about it, guys. A chessboard has 8 times 8, 64 squares. So how many on the last one? Okay, so let's take a look here. So in the first one, it was 1 grain of rice. The next one is 2, which is basically 2 to the power 1, right? Now, if you double it, the third square is going to have 2 to the power 2. The next square is going to have 2 to the power 3. You guys are getting the pattern, and so on, right? So we can all put this into the powers, right? So 2 to the power 4, 2 to the power 5, because every time we are doubling it. Right, guys? So how much in the last chessboard? You're almost right. It's going to be very good. I see Namita has the right answer, right? Murli has the right answer. Okay, Ansh, very good. It's going to be 2 to the power 63. So you guys are almost right, because the first square actually had 1, not 2. Okay, so it's going to be, because it's going to be 2 to the power 63, because we multiply 2 63 times, because the first one had, right? So the first one had 1 grain of rice. So see how easy it becomes with exponents. So I'm going to remove this answer. So the last square will have 2 to the power 63 grains. And in fact, I think the king's supply finished off in the middle of the chessboard, because it's a huge number, right? So, but we can conveniently express it as 2 to the power 63 even without calculating. Excellent. Yashwan, Nikhat, you guys have the right answer. Neeraj, superb. All right, guys. Now let's go ahead to the laws or the theories behind exponents. So we are going to be looking at some interesting rules here, right? And before we look at the rules, let's talk about the terminology. So what do we mean by, so this is 5 square, right? So it's basically 5 into 5, that's 25. And this notation 5 to the power 2 is called 5 squared, right? You've all heard of this. Like we say x squared, y squared, this is 5 squared. Similarly, here we mean 3 times, right? 5 multiplied 3 times. So 5 to the power 3 is called 5 cubed. Right, guys? So it's 5 raised to the power 3. And similarly, this one is called, typically, we just call it, it's 4 times, right? We multiply the number 5 and it's called simply here 5 to the raised to the power. Okay, let me write that again. So 5 raised to the power 4. Right? So just be clear about these terminology and the names, and very good, it's going to work out to be 625. Excellent, right? You just have to multiply the numbers. So you can write it like this. Superb. So now I'm going to show you the laws of exponents or rules of exponents in a very simple and interesting way. We're going to work it out with the help of simple examples. Okay, so I'm going to make the concepts crystal clear to you. So guys, be sure to watch this entire class. Okay, it's very important for everyone. So let's take a look here. What do we have? We have 2 cube times 2 squared. So what is this going to work out to be? So 2 cube is basically 2 into 2 into 2 3 times, right? And then we are multiplying that by 2 square, which is 2 into 2, right? So if you count this, what do we have here? Basically, we have 5 2's, right? If you count all of it, very good. So you guys are saying it's going to be 2 to the power 5, right? Because you have 5 2's in this expression, correct? Right? And we have, so 2 cube times 2 square is giving us 2 to the power 5. Now, if you carefully look here, why do we have that? Because you have 3 2's here and 2 2's, right? So basically what we were doing is we are adding the powers. So it's basically 2 to the power 3 plus 2. Can you see? Because we have 5 of them, which is basically equal to 2 to the power 5. Right, guys? Okay. So can you see that? We are basically adding the powers. 3 plus 2. So we can make this general rule, guys. So what is the general rule going to be? So let's write it here. So if you have a number a to the power m, right, and you multiply it with another number a to the power n, right, you can basically add up the powers like we did here. So 3 and 2, the powers got added up and it's 3 plus 2. Very good. It's going to be 32, right? So what is this rule? We get a to the power m plus n. So guys, if you have the same base a, right? So when you're using the same base a and you have the powers m and n and you multiply them with the same base, the powers add up, right? Excellent, right? Very good. So because here, what is the same base here, guys? Can you know? The same base is 2. Okay. So you can't do this for example, if you try to do this for 2 cube into 3 square. Can I apply this rule, guys? For 2 cube into 3 square, can I use this important rule that we just derived, right? Where if you have the same base, you add up the powers. So can you do that? No, very good. Satya says no, right? Because what is the problem here? The base is not the same, right? So we cannot do it because base is not same. Okay. So this is the first rule that we've learned today, that a to the power m multiplied by a to the power n is going to be a to the power m plus n, right? Where you have the same base a. Excellent. Now let's take a look at another rule. Now let's say you're dividing exponents, right? So you have 2 to the power 7 divided by 2 to the power 4. Okay. So what does this work out to be? So let's do it. So we have 2 to the power 7 here divided by 2 to the power 4, sorry, right? So now let's write this clearly. So what is that basically? So we have 2 into 2, 7 times, right? So 3, 4, 5, 6, 7. Do I have 7 there? 1, 2, 3, 4, 5, 6, 7. Yeah. Divided by 4 times here, right? And can you see stuff is going to get cancelled here? So can you see, guys, here that these guys are going to get cancelled. So these 2's will get cancelled, right? And how many 2's are we left with? Okay, very good. Mitra says 2 to the power 3. Raghupati says that. Very good, guys. So we are going to be left with 2 to the power 3, right? Okay. So basically what is that? It's because the 7 got cancelled by 4. There were 4 2's down there, right? So basically we did 7 minus 3, which is, 7 minus 4, right? Okay. And which is basically equal to 2 to the power 3. So when you're doing division with the same base, you're basically subtracting. Previously for multiplication, we were adding the powers. Here we are subtracting the powers. So we get 2 cube, right? Which is of course the number 8. And you can do the division and check also, right? So if you divide these two numbers, you're going to end up with 8. So our answer is correct here, right? Very good. So because 8 is basically 2 cubed. So you can check it also, right? So what is the rule that we are arriving at here? So the rule we are getting is a to the power m, right, divided by a to the power n. What is it going to be, guys? A to the power m minus n, because note here the powers got subtracted, right? So this is our second important rule, that when you have the same base, guys, when you have the same base, you basically subtract the powers. Simple, right? And we showed it with a very simple example. Excellent. Now let's take a look at another rule for exponents. So let's say now we have this 2 to the power 4 divided by 2 to the power 7. So let's see what's going to happen here, right? So what do we have here? So 2 to the power 4 divided by 2 to the power 7, right? And so we can use the previous rule, right? Because you have the same base here, 2, right? So we can subtract these. And what do we get by doing that? So we are going to get 2 to the power 4 minus 7, right, guys? If we use our previous rule, which was this one, a to the power m minus n. So we are going to end up with, what are we going to end up with here? We are going to end up with 2 to the power minus 3. Okay, very good. So 2 to the power minus 3. And let's say you just solve it normally. What will you get here? 2 to the power 4 by 2 to the power 7. So you typically, you'll cancel this and you're going to end up with, so the basically there's going to be 4 2's on top on the numerator and 7 2's in the denominator. So we are going to have 1 by 2 cube here, right? So if you compare these guys, right? So here we solved this, right? Guys, can you see? So we solved it 2 different ways and we have 1 by 2 cubed and then we used our formula, right? 2 to the power minus 3. So what is the conclusion we are getting? And both of these are same, right? So this is equal to this, right, guys? So what is the important conclusion we are getting here? That basically we are having 1 by 2 cube is equal to 2 to the power minus 3, right? So when you have it in the denominator, basically in the power it's going to be, so you have taken a reciprocal of 2 cube, it's basically 2 to the power minus 3, right? So how do we write this rule? That if you have a to the power minus n, right? Okay, so this part, so if you have 2 to the power minus 3, if you have a to the power minus n, it's basically 1 by a to the power n, right, guys? Or we can write it as a to the power n is equal to 1 by a to the power minus n. So this is our, I think, third important rule that we've learned today. Okay, so please take a look. Very simple example we are comparing. So if you have a to the power minus n, guys, take a look here. This rule I'm talking about right on top here, a to the power minus n. So you have a negative power, it becomes 1 by a to the power n. Okay, and similarly a to the power n. So if you cross multiply this, you're going to get 1 by a to the power minus n. Okay, simple, guys, very easy, right? So this is our another important rule. Now let's take another law or rule of exponents. These are also known as laws of exponents or rules of exponents. Okay, and there are quite a few of them. So you should really, we are going to take a look at the list and you should apply them correctly when doing the sums. So first you should understand the rules. So what do we have here? 2 square whole cubed, right? So we have 2 square there and whole cube. So come on, guys, what is this going to be? So if you do this, this basically means 2 square times 2 square times 2 square, right? I'm not even expanding anything here, right? I'm not calculating. We are all working in exponents because 2 square whole cubed. So what is inside this bracket? We are doing multiplying it 3 times, right? Because it's to the power raised to the power 3. Okay, so let's apply that rule that we had learned, right? So when you multiply things, what happens to the powers? The powers get added because can you see the base is same? So it's going to be 2 to the power 2 plus 2 plus 2, right, guys? So that's going to be 2 to the power 6. Are all of you seeing that? Okay, it's going to be 2 to the power 6. Excellent. Very good, guys. It's great to see everyone interacting and trying it, right? So don't believe what I'm writing. You should always be thinking and trying. Okay, excellent, guys. So 2 to the power 6. And if you take a look at this, so what is effectively we are doing? Since we are adding 2 3 times, we are basically multiplying these powers. If you notice here, guys. So please take a careful look. So what we are doing basically, when you have 2 to the power 2 to the power 2, 2 to the power 3, 2 whole to the power 3, it's basically you're multiplying it out, right? And that's why, so this is effectively a multiplication of these powers. So what is the rule that we made here? If you have a to the power m and that whole thing to the power n, okay, effectively you're basically doing a to the power mn. Does that make sense, guys? Can you see that? So you're basically multiplying the powers, right? A to the power m and whole to the power n. And can you see, guys, the power, let me write n clearly, the powers get multiplied here. Okay, so this is our multiplication of the powers. Excellent, clear? So this is our, I think, fourth rule. Okay, I hope I have my numbering correct, right? There are a lot of rules here. So we are right now on the fourth rule of exponents. Excellent. So now let's take a look at this next one. What do you think 2 cube by 2 cube is going to give us? So come on, I want you to try, right? So what do we do here? So if you go the normal way, right? It's pretty simple. So 2 cube by 2 cube, right? It's basically, or if you want to check it, it's right, 8 by 8. So it's basically 1, right? And now if we apply our exponents, what do we get here? Very good. It's going to be 1. And if we apply our exponent knowledge, since we have the same base and you're doing division, right? It's 2 cube by 2 cube. So what can I do here using exponents? It's going to be 2 to the power 3 minus 3, right, guys? 3 minus 3. Why? Because in division, same base, you're subtracting the powers. We're using a to the power m minus n, correct? And what is 3 minus 3? 2 to the power 0. Okay, so what is our conclusion here? If we solved it this way, we got 1. And if we solve in terms of exponent notation, we are getting 2 to the power 0. So our conclusion is 2 to the power 0 is equal to 1. Very, very important conclusion. Excellent, guys. 2 to the power 0 is 1. Harry says that. Very good, right? Mitra says that. Excellent. So that's our conclusion. And in fact, what is our main conclusion here? Anything to the power 0. So a to the power 0. So any number that you're taking, right? A to the power 0 is equal to 1. Very important. So whether it's, guys, whether it's you're taking 2 to the power 0 is 1. A lot of students get confused with it. 3 to the power 0 is 1. 10 to the power 0 is 1, right? 50 to the power 0, anything to the power 0 is 1. Okay, very, very important. Okay, because a lot of times you guys forget this important rule. Okay, and what is the confusion here? Because please remember, a times 0 is 0. So if you multiply it, a by 0, it's 0. But a to the power 0 is 1. Okay, so guys, don't confuse this. Okay, so a to the power, a multiplied by 0 is 0. So I don't want you to confuse with that. I'll erase that out. But a to the power 0, the important rule here we've learned is a to the power 0 is 1. Anything to the power 0 is always 1, as Anjali is saying, right? So I reminded you, please remember, anything to the power 0 is 1. Excellent. So now let's take a look at this. So let's say you have 2 times 3. So we are getting into more interesting and complex examples. So if you have 2 times 3 whole cube. So what do we write here? So it's basically 2 times 3, again multiplied by 2 times 3, right? Multiplied by 2 times 3, right? And we can group these guys together. So basically what do we have? 2 times 2 times 2 into 3 times 3 times 3. Can you guys see that? Okay. So what are we basically finally getting? We have a 2 cube multiplied by a 3 cube. Okay. Can you guys see that? Very good. So you have a 2 cube multiplied by a 3 cube here, right? And this is what we had on our left hand side, right? Basically we had 2 times 3 whole to the power 3. So if you carefully look at this, compare the left and right hand side, what conclusion can we derive from here? So we can derive this very important rule, right? That what is the important rule? A times B. So let me write that clearly. So A times B whole to the power n is equal to a to the power n times. So this dot means multiplication, right? So it's not a decimal point, it's a multiplication in maths. So a dot b, or if you like it, we can write this rule like this. A multiplied by b to the power n is equal to a to the power n multiplied by b to the power n. So basically the powers are going into A and B. Okay, very important rule. Yes, some of you are calculating 216, the answer 6 cube, excellent. But here the important thing is, please note the rule that we are learning based on the example. We are coming to this conclusion, right? Using this example, we have come to the conclusion a times b to the power n. Basically, you can expand it. A to the power n times b to the power n. Excellent. Now let's take a look at this. So similarly, what will this be, right? What do you guys think this is going to be? We can do the same thing here. So this is, we have 2, right? We'll have 2 times 2 times 2 here, divided by 3 times 3 times 3, right? So this is going to be 2 cube by 3 cube, right? And where did we get this? Because this is 2 by 3 3 times, right? So 2 by 3 3 times, right? So can you see this? So this is what we have. So our left hand side is basically 2 by 3 whole cube is basically 2 cube by 3 cube. So what is our important conclusion? Very similar to the previous one, right? So then if you have this kind of fraction form, a by b to the power n, right? So if you have a by b whole to the power n, it's basically going to be a to the power n by b to the power n, right? Just like there we had a times b to the power n is a to the power n times b to the power n. Here we have a by b to the power n is a to the power n times b to the power n, like we got from this simple example. Okay, so that's going to be rule number 7 for us. Clear, guys? Very simple. Okay, excellent and awesome. I see all of you are participating and being very interactive. And guys, if you're enjoying this session, please hit the like button right now, right? Please hit the like button. Thanks a lot, guys. And do share it out with your friends so that we can have more people join the Manocha Academy family and join our live classes on this channel and also on our website, manochaacademy.com. So thanks, guys, for your love and support. And let's continue the rules. So what do we have here? So this is an interesting case. We have 2 by 3 to the power minus 4. Okay. So what are we going to get here, guys? So this is going to be, if you expand it, so we'll use our previous rule. Remember this rule we are using. So a to the power n by b to the power n. So we can write this as 2 to the power minus 4 divided by 3 to the power minus 4. Right, guys? Okay. And remember, if it's the negative part, what happens? This will go on top. So you will get 3 to the power 4 divided by 2 to the power 4. We are using that rule, right? A to the power minus n is 1 by a to the power n. Clear, guys? And so if we simplify this, we can group this like this. It's going to be 3 to the power 3 by 2 to the power 4. So do you guys agree with me? Are you with me here, guys? So very simple simplification we've done, and we are getting this. So the left and right hand side. Thanks, guys. I see a lot of you hit the like button. Thanks a lot. And we have folks from all over the world joining us. Thank you, guys, for your love and support. So please take a look at this. Is this making sense? So what simple rule we can derive from this example that we've done, guys? So we can say the rule is going to be, what is our rule here? A by b, right? So 2 by 3 is an example. So where you can have any numbers, right? So a by b to the power minus n, right? 4 is just an example, is equal to b by a to the power n, right? So you basically take a reciprocal and the negative part becomes a positive part. So very important, just practice these rules a couple of times and you can apply it in your sums. Okay, excellent, guys. Clear? Very good. So does this make sense? Let's go on to some more interesting rules. This is a very interesting one. So come on, can you tell me what is minus 2 to the power 1? I want all of you to try, guys. So thanks a lot. I see a lot of you are liking and enjoying this session and our videos. Thanks a lot, guys. So please tell me, guys, what is the first line going to be? Very good. Jay Reddy Priyal says minus 2. Excellent. So minus 2 to the power 1 is going to be minus 2. Who can tell me the next one, guys? Minus 2 whole square. Come on. I want all of you to try here, guys. Very good. Oswin says 4. Nizi says 4, right? Kirit Ghosh 4. Very good, guys. So this is going to be minus 2 whole square because it's basically minus 2 times minus 2, right? And you can see that. So the negative sign will cancel out, right? Minus minus becomes plus, right? It multiplies. So we get 4. Excellent. Now what is minus 2 whole cube? Okay. Excellent, guys. Excellent. What is minus 2 whole cube? Very good. You guys are already ready with the answer. So it's minus 2 into minus 2 into minus 2, right? So that's going to be minus 8, right? And what about the last one? Minus 2 raised to the power 4. Come on, everybody try here. Okay, these things seem simple, but you know, we make careless mistakes, right? So we should be clear about them. Very good. So I see Shreyash says 16, right? Adiraj, excellent guys. So this is going to be 16 because again, they're going to be 4, right? So this is going to be minus 2 times minus 2, 4 times, right? And so you can see they're groups of 2, right? They're pairs. So the minus will cancel out in pairs. We have a positive sign. Can you see? So we have plus 4 here and we have plus 16, but these are negative. So what is our important conclusion, guys? That when you have the minus sign, it's raised to the power an even number, right? Like these. So when you have the even number, then you're going to end up with a positive sign, a plus. And when you have minus, right, raised to the power of an odd number like 1 or 3, right, over here, then you're basically going to end up with a negative number. Can you guys see? So minus 2 to the power something odd will be negative, okay? Because in pairs it will cancel and one minus will be left, right? But when you have to the even number, then you'll have a positive sign. Excellent. Clear, guys? Okay. So please remember this very important rule, right? So we did this rule here, and I think last one was, so we had rule number 7. So this was our 8th rule. And so this is going to be the next one. This is going to be our 9th rule that we looked here, right? Very important. So that you know how to multiply with the negative numbers. Crystal clear? Excellent, guys. So now can you tell me what is minus 1 raised to the power 101? Come on, apply your maths and do this. Come on, guys. So who can tell me this? Is it going to be A, B, C or D? So minus 1 raised to the power 101. Come on, all of you. Okay, some are saying minus 101, some are saying minus 1. So what is this going to be? Come on, guys. So minus 1 raised to the power 101, it basically means minus 1 times minus 1 times minus 1. You keep multiplying it, right? I think we'll go on the whole day because it's going to be 101 times. Okay, so minus 1 is multiplied with minus 101 times. Okay, so all the ones are going to multiply, right? 1 into 1 into 1. So that's going to be 1. That's simple, right? So 101 is not going to be the answer because it's just multiplying with 1, right? You know, 1 into 1 is 1 times 1 is 1. Again, into 1 is 1. But what about the sign? Let's apply the rule that we just learned, guys. What is the rule? That a negative number to the power even will be positive and negative number to the power odd. Please take a look here. Here's the rule. And you can see that 101 here is an odd number, right, guys? The power here, our power is an odd number. Excellent, guys. Excellent. Anshuman Gupta says minus 1. Right. Very good. So Albert Einstein says minus 1. Adarsh Mishra, right answer. Absolute bingo, guys. So it's going to be minus 1 because you have an odd number. So there will be a minus sign left. Clear? Superb. Now, guys, try this question. What is minus 2 power 4? So who can tell me this answer? Come on. This is our next question. Excellent. Naman, Taslima Khan, minus 1 is the right answer. Now try this question, guys. Minus 2 to the power 4. Okay. Yeah, sorry if I'm not taking everyone's name, guys. Please forgive me. It's great to see the participation, and you know the chat keeps rolling pretty fast, but I'm keeping an eye on it. And guys, if you haven't hit the like button, please hit it right now and hit the subscribe button for our channel. Thanks, guys. Come on. Okay, a lot of you are saying 16. Okay, I see a lot of 16's answer here. Some are saying minus 8. Let's take a look. I think this is a little tricky one. Okay, guys, be careful. This number is different from, so minus 2 to the power 4 is not same as writing minus 2 whole to the power 4, guys. Be careful. Okay, so 16 is not the right answer because for this one, so minus 2 whole to the power 4 basically means minus 2 times minus 2 times minus 2 4 times. Okay, so there we can apply our rule. 2 times 2 times 2 is that's 16. And since we have the minus sign multiplied 4 times, we have a even power, so it's going to be plus 16 for this one. Okay, so this answer is going to be plus 16. But guys, be careful about this notation. So I purposely, gave a little tricky question here, that when we write minus 2 to the power 4, this basically means minus 1 into 2 to the power 4, if you want to think it that way. Or basically the minus sign is in front. Okay, it has nothing to do with the power. So the minus sign is away from the power, guys, right? So it's basically minus 16, right? Okay, so Shibam Patra, Srinivas, right? Ready? That's the right answer. It's minus 16, not 16, guys. Please carefully note about this notation versus this notation. Okay, minus 2 to the power 4 is not same as so this guy minus 2 to the power 4 is not same as minus 2 whole to the power 4. Okay, so very good, guys. The answer is going to be minus 16 because the negative sign has nothing to do with the power here. Okay, so here we are separating the two. Excellent, guys. Excellent. Superb. So let's talk about some more. Okay, there are a lot of laws and rules for exponents, and that's why, this chapter sometimes becomes a bit difficult and confusing, but believe me, I'm trying to make it as easy for you. So guys, please pay attention here. Let's take a look. If a to the power m is equal to a to the power n and a is not 1, okay, then we can say m is equal to n, right? So what are we saying here? And here, guys, a is a positive number. Okay, so the a we are taking is we're considering a positive number, right? So basically what we are saying, if the bases are equal, so carefully follow me, guys, here. If the bases, a is the base, remember, if the bases are equal and the numbers are equal to each other, then we can say m is equal to n, right? So let's take an example, right? So if we have something like 2 to the power 3, right? We can say it is equal to 2 to the power 3, right? So basically here you have the base is 2 and then these powers have to be equal if the bases are equal, right? And the base, of course, a should not be 1 because 1 to the power 5 can be equal to 1 to the power 3 or equal to 1 to the power 7. Okay, so if the bases are equal, then the powers are also going to be equal. Okay, so if you have two equal numbers and the bases are equal, the powers are equal. But this, of course, is not equal to, if you have, let's say, the base 2, you can't have, it's not equal to 2 to the power 4 or it's not equal to 2 to the power 5. Right, guys? Okay, so 2 to the power 3, we can say is equal to 2 to the power, basically, when you're equating the numbers, if the base is same here like here, then the powers will be exactly the same. M is equal to n. This is our m, this is our n. Right, guys? But there's another interesting example. So if you take 2 to the power 4, that is equal to 4 to the power 2, right? 2 to the power 4 is 16. We can also express it at 4 to the power 2, but we can't apply these rules here because the base is not same. Can you see, guys? Here the base is different. So we can't equate the powers. We can't say 4 is equal to 2. So here our rule cannot be applied because the base is different. Okay, but when the base is same and two numbers are equal like here, can you see? So when the base is same, guys, and the numbers are equal like in this case, then we can say the powers are equal. Excellent, guys. Very good. Now let's take a look at another important rule for exponents. If a to the power n is equal to b to the power n, right? So if you have these two things equal, right? So if, what are we saying? If a to the power n is equal to b to the power n, and again here, guys, a and b are both positive numbers, and the power n is not equal to 0, then we can say that a is equal to b. That means the bases are equal. So if you have two equal numbers, a to the power n and b to the power n, right? And the powers are equal. Can you see the same power here, guys? Take a look. It's the power n. So the powers are equal, and if the numbers are equal, that means what is the conclusion? That a is equal to b. So we can conclude from here that the bases must be equal. Clear, guys? Okay. So if a to the power n is equal to b to the power n. So basically, what do you have here? Like, if you have something like, let's say it's 3 to the power 5, right? is equal to x to the power 5. Okay, so guys, if I say this, 3 to the power 5 is equal to x to the power 5. Therefore, what is the value of x? Can you tell me here? Based on this rule, what should be the value of x? Come on, guys. So apply this rule. Can you see the powers are same? 3 to the power 5. Very good. Vinay says 3, right? Kirith, ready, right? Excellent. So the x will equal to 3. Simple, right? Because if you have the powers are equal and the numbers are equal, we get that. Similarly here, guys, same thing for the previous one, right? If a to the power m, so here, if you guys are not clear, we can give another example here. So suppose here what you had, like 2 to the power, let's say we have 2 to the power, or let me take a different number, guys. Let's take 3 to the power 4, okay, is equal to, let's say we have 3 to the power x. So can you tell me what is x? So come on, guys, if you have 3 to the power 4 is equal to 3 to the power x, then what is x going to be in this case? So, right, it's going to be 4 because we apply the simple rule. Can you see the bases are same, right? So the exponent, the power has to be same. So therefore we apply x is equal to 4. Simple. So that's how we apply these rules. It looks like common sense, but we must understand the rule and they work for the positive numbers here. Okay, excellent. Now let's talk about root or radical. This is also a very important thing and there's a lot of confusion with roots or radicals, right? So let's be clear here. So guys, what is square root of 9? Okay, and you know this square root of 9, we can also write it as the 2 is missing, right? So basically you can write the 2, but when we don't write the 2, we know it's a square root. Okay, so everybody knows square root of 9 is 3, right? Excellent. So let's see if we evaluate it like this. So basically we have square root of 9 is basically, this is defined as 9 to the power half. Okay, so in terms of exponents, when you have this root, square root, it basically means to the power half. And let's check your answer. So let's use our exponent knowledge. So what is 9, guys? It's going to be 3 to the power 2. And that is raised to the power half. Okay, so guys, can you see 3 to the power 2 to the power half? So I need to multiply the powers here. So it's going to be 3 and 2 to the power half, right? So we'll multiply these. The 2 will get cancelled. We get 3 to the power 1, which is basically 3. Okay, so what is our conclusion? The square root, look here. So the square root sign basically means raised to the power half. Can you guys see that clearly? Raised to the power half. Very important. Similarly, what does this cube root mean, guys? Okay, so if you apply the same knowledge, cube root of 8, it basically means 8 to the power, who can tell me? 1 by 3. Right, guys? So please know this. A lot of students get confused with the root or radical. Cube root of 8 means basically 8 raised to the power 1 by 3. Excellent, right? And so, yeah, you know cube root of 8 is 2, and let's work it out with our exponent knowledge. So this is going to be 2 cubed to the power 1 by 3. And can you see the 3 and 3 will get cancelled? It's 3 to the power 1, 3 times 1 by 3. So 3 gets cancelled here. 2 to the power 1, which is 2. And that's exactly what you guys told me, right? So cube root basically means, look here, cube root means to the power 1 by 3, 1/3, right? And similarly, if we generalize this, right? If we have any number a with a root of n, right? Nth root of a, it's basically going to be a to the power 1 by n. Very, very important, guys. Be clear here, a to the power 1 by n. And what about the last one, guys? So is this clear to you? Okay, or if you want, you can write this clearly like this, a to the power 1 by n. Okay, a raised to the power 1 by n. And what is this thing going to be? A to the power m by n. Okay, right? Because you have a to the power m there, and then, so if you want to understand how does this work out, so this is basically a to the power m whole raised to the power 1 by n. So if you multiply the powers, you're going to get a to the power m by n. Very, very important. Excellent, guys. Anjali says a to the power m by n. Excellent. Sri Lakshmi says that, right? Excellent, guys. So you got this. Please be careful. These are very, very important rules. A lot of students get confused with this radical or root. We call these, or they are also known as surds, right? So the square root, cube root symbol, it's basically to the power half, to the power 1/3. When you have fourth root, to the power 1 by 4. And this is how you can learn the general form. root of a to the power 1 by n, or this last one, right? A to the power m by n. Excellent, guys. Simple. Now, come on. Can you calculate this for me? What is this number? Fourth root, right? So, yeah, it's known as surd. So, we have a fourth root of 81 here, right? So, who can tell me what is this answer? Come on. So, come on, guys. Write down the answer. All right, very good. Okay, excellent, guys. Excellent. I see a lot of Lalita has the right answer. Lavanya, very good. Superb. So this answer is going to be 3, right? And let's see how we can work that out, guys. It should be simple for you now. So how do you rather than calculating, let's apply exponents, right? So rather than just guessing out the answer, how do we apply our exponent knowledge? This is basically going to be 81 to the power 1 by 4, right? See, I've taken this fourth root and written it as 1 by 4. And what is 81? 81 is 3 to the power 4, right? And we know that these powers will get multiplied. A to the power m times n, right? So 4 times 1 by 4. Excellent. So the 4 will cancel there. It's 3 to the power 1. Superb. You guys rock. The answer is 3. Excellent. Okay. Let's move on to the next question. Michael Faraday says 3. So right answer. Guys, what is this going to be? Cube root of 9. Who can tell me? So come on. I want all of you to try. And awesome to see the participation. Guys, please hit the like button and do share it out with your friends so that we can have more people on the Manocha Academy family. Come on, guys. I see a lot of answers here. 3, 3. Okay, what do you guys think? What is cube root of 9? Guys, be careful. This one is an interesting question. Okay. I think Oswin has the right answer. Come on, guys. Who's trying here? Okay. I don't think it's 3, guys. Square root of 9 is 3. Be careful. What is this going to be? Let's work it out. So cube root, when we are writing cube root of 9, what do we really mean? It's 9 to the power 1 by 3. Okay, it's 9 to the power 1 by 3 because cube root means to the power 1 by 3. And what is 9 in terms of exponents? 3 square to the power 1 by 3, right, guys? And now you're going to multiply the numbers. Okay, so it's going to be, we're going to multiply the powers, right? We're going to multiply these powers, the 2 and 1/3. So we are basically going to get 3 to the power 2 by 3. Guys, can you see that? Because what are we doing here? We're going to multiply 2 times 1/3. The powers here, right? The powers are getting multiplied. So we get 3 to the power, let me write that a bit clearly, 3 to the power 2 by 3. So this is our answer, the cube root of 9. So guys, don't be in a hurry. A lot of you said C, A. The correct answer is C here, guys. 3 to the power 2 by 3. Excellent, excellent. Okay, Satya says that super Subi ready. Okay, K Gautam, C is the correct answer. So be careful with your exponent, guys. So here's a summary of what all the rules that we learned, guys. And you can take a screenshot of this if you want. Please write them down. And the main trick is, guys, when you look at the question, you need to see which rule you applied. So these are all the rules that we learned. A to the power m plus n, m minus n, then these reciprocals, right? A to the power m n, then a to the power 0. Anything to the power 0 is 1, okay? Though 0 to the power 0 is, undefined, or sometimes it's defined as 1, sometimes 0 for convenience. There's a big debate still, I think, on 0 to the power 0. But if the number is not 0, anything to the power 0 is 1. And then you have these important rules that we looked at today. And plus we have all these rules that we did. So guys, you can take a screenshot of this and please write them down. And so this is the whole summary, right? This one, and guys, this one. Okay, and please practice this. So when you look at the question, you need to recognize which rule you need to apply. And now I've got an interesting question for you based on Einstein's famous formula, guys. E equal to mc square. You must have heard of this mass energy conversion. So let's use our maths knowledge for science. Come on. So can you find the amount of energy released if 1 kg of mass is converted to energy? And what is C? C, guys, is the speed of light. We talked about that in the beginning of the class. 3 into 10 to the power 8 meter per second. So come on, guys. Yes, Albert Einstein's famous formula. We have Albert Einstein also on the class here, right? So come on, guys. Calculate and tell me. Use your maths knowledge. So we are going to use the formula E equal to mc square. We want to find the energy when the mass given is 1 kg, right? So the mass here, guys, okay, the mass given to us is 1 kg and c is the speed of light. 3 into 10 to the power 8 meter per second. So come on, and you don't have to worry too much about the units. It's going to work out to joule. So which one do you think is the answer? Come on. All of you. A, C, okay, I see a lot of answers here. D, which one do you think is the right answer here? So let's work it out together, guys, and check your answer. So let's see if we can apply our exponent knowledge for science, right? Because I'm telling you, these exponent chapters all over the place in maths, science, right? Physics, chemistry, biology, everywhere, right? Wherever you're multiplying these big and small numbers. So let's take a look. It's 1 kg, right? I'm going to leave the units because it's going to be joule, right? The SI unit. So mass is 1 times 3 into 10 to the power 8 whole square. Oops, okay. 3 into 10 to the power 8 whole square, right, guys? So what are we going to get here? So it's going to be this number whole square. So now how do we square this guy, right? Can you see? So let's apply our knowledge. We can use this rule, right? We learned that AB to the power n is A to the power n times B to the power n, right? So basically we are going to do, it's going to be, so we don't care about the 1. It's going to be a 3 square. Can you see that? So 3 square times 10 to the power 8, because those are our two multipliers, whole square. Do you guys agree? Okay, can you see that? So I'm using my AB to the power n knowledge here. Remember this rule? So A to the power n, so it's going to be 3 to the power 2 and 10 to the power 8 to the power 2. So come on, now let's work it out. So energy is going to be basically equal to 3 times, so 3 square is 9 and 10 to the power 8. What rule can we apply here, guys? So here we can apply this rule, right? A to the power m whole to the power n is basically A to the power mn, right? Because 10 to the power 8 whole squared, whole to the power 2. So what are we going to get, guys? 10 to the power 8 times 2. Do you agree? 8 multiplied by 2. So it's going to be 9 into 10 to the power 16 joules. Okay, so that's going to be our answer. Excellent, excellent, guys. A lot of you have got C. I see Lalita Kumari, Subhi Reddy, Priyal Kothari, Ansh Kumar, Albert Einstein. Excellent, guys. Very good. 9 into 10 to the power 16. And see how we applied our maths knowledge to solve this question. So guys, don't make sure you don't make a mistake. All right. And I have one very interesting question for you. Let's say we have a planet of radius 3 into 10 to the power 5. Okay, I don't know if there's a planet like that. I just made up the question for you guys. So we have a planet of radius 3 into 10 to the power 5 meters. You need to find the volume of the planet for me, and do let me know your answers by putting it in the comments below. So some of you who are not sure of the volume formula, guys, you know, because here our focus is on exponents, right? So you know the planet is a sphere, approximately a sphere, right? And what is the volume formula? Who can tell me? What is the volume of a sphere? Come on, guys, who can tell me? What is the volume of a sphere? Okay, volume of a sphere is 4 by 3 pi, let me write the 3 clearly, 4 by 3 pi r cube, right? Okay, and you can take the approximate value of pi. You can take pi to be 22 by 7, the approximate value, okay, or 3.14, whatever value you want, right? So 4 by 3 pi r cubed, okay? Can you see there's an exponent there? So guys, I want all of you to try, and do let me know your answer by putting it in the comments below. I know a lot of you are fast and you immediately reply. I want each one of you to try, and I promise to take a look at your answers. So do write them in the comments below. And guys, thanks for joining on this session. And as I said, we have this website, manochaacademy.com. Guys, do check it out. We have these awesome courses on great discounts. It will be really helpful in your CBSE Class 9. We have CBSE Class 9 and Class 10 courses, and we have the ICSE Physics Class 9 course. So I'll put the links below. Guys, do check it out. And because you get to attend more live classes. I take more live classes on our website. You get to watch interactive videos and get replies and clear your doubts, you know, and there are quizzes and questions. So guys, do check it out. And you know, yesterday, sorry about it, I couldn't have the class because we had this huge sudden thunderstorm, and there was a lot of lightning, and there's a huge voltage fluctuation. So I got really scared and I had to turn off my desktop, because I didn't want to ruin my desktop with the voltage fluctuation. So sorry guys for postponing this class to today. But actually, the weather forecast in Calcutta this week is really bad. So I'm from Kolkata, India, and there's scattered thunderstorms. First, last week we had the cyclone Amphan, and now we have these scattered thunderstorms. So guys, I hope I'll be able to take a class tomorrow. In case the weather is bad, guys, the next class will definitely be, I think by Monday it will be cleared up. So Monday 8 p.m. and if possible, I'll try to take a class tomorrow also. So it'll probably be a physics class. Guys, do you want a class on electricity? So how many of you want a class on electricity on physics? Can you let me know here? So guys, are you interested in a class on electricity in physics? Okay, some are saying yes, some are saying no. Okay, I'll try to take, because I got a lot of requests for the electricity topic, so I might try to take that tomorrow, otherwise Monday at 8 p.m. So guys, do join us, and if you haven't subscribed to our YouTube channel, hit the subscribe button right now. Please like this video and click on the notification bell. And as I said, check out our courses. We've just launched the Math CBSE Class 9 course yesterday. So I know a lot of you have already signed up. Guys, please take a look and sign up. Thanks a lot. It was a great session. I really enjoyed it. Hope you enjoyed it. So this is Sandeep Manocha signing off. Take care, everyone. Thanks a lot for joining, and do share it out with your friends. All right, I'll end this session. All of you, please take care of your health and keep studying, keep happy, be happy, and keep learning. All right, guys, bye.